Today we're covering 8th grade, Chapter 1, Lesson 7, the real number system. And yes, there is a number system that's not real. It's actually called imaginary. But I'm going to let your high school teacher discuss that with you. We're just going to stick with real numbers. So far, you should know about rational numbers. And rational number is any number that can be expressed as a ratio. And a ratio is a fraction or a comparison of two numbers where a and b are integers and b is not equal to 0. So you've seen so far everything but this side of the graph. You've seen rational numbers, integers, whole numbers, and natural numbers. Now we're going to talk about irrational numbers. They're just wild and crazy. So an irrational number is a number that cannot be expressed as a ratio. So a rational number can be written as a fraction. These really cannot be written as a fraction. Real numbers include rational and irrational. So we're going to place some of these into the Venn diagram. 1/2, which can be written as 0.5, is a rational number. 0 is a whole number. -8 is an integer. 0.4 repeating. We've already learned that repeating decimals can be written as a fraction. That would be written as 4/9 because repeating decimals have 9s on the bottom. So that's indeed a rational number. And then -3 is an integer. 10 is a whole number. It's also a natural number. 18% could be written as 18/100, so that is a rational number. 9 is a natural number. -3/4, that's a fraction, and that would be irrational. 4 is a natural number. And 0.45 could be written as 45/100, so that's rational. And then we have this 0.16, that could be written as 1/6, which is a fraction. So 0.16 repeating goes in the rationals. What about the square root of 2? What would that be as a fraction? You could put it in the calculator and check. It's one of those weird ones that goes on and on, so that is irrational. And you should know pi. Pi is one of those. This is a weird symbol right there. It's a number that goes on forever. We round it to 3.14, but it can go on forever without repeating, so it can't be written as a fraction. That means it's irrational. Pi, that's the Greek letter right there, is equal to 3.141592655, and it goes on and on. Pi does not repeat, nor does it terminate, so it can go on indefinitely. It cannot be written as a ratio. Therefore, it is irrational. The same for the square root of 2. It equals 1.4142135562, and it keeps going on and on. The square root of any number that is not perfect. So if it doesn't come out to be a perfect square root, a perfect square number, like 36 is a perfect square root of 6. then the number is irrational. Let's do some examples. We're going to classify each number by determining all sets of numbers to which it belongs. So 4 1/2, I could write that as just a fraction. It would be 21/5. It's not a whole number. So it's not the opposite of a whole number. It's only a fraction, so it is rational. And if it's in the rational category, it is also real. 3. 3 goes into the tiniest circle. So it is a natural number. And if it's a natural number, it's also a whole number. And if it's also a whole number, it's an integer. And if it's an integer, then it is also a rational number. And if it's a rational number, it's in the big category of real. So it's all of those. If it goes into the tiniest circle, then it's all the bigger circles. 0.7 repeating can be written as a fraction, 7/9. Therefore, it is a fraction, so it's not natural, it's not whole, it's not the opposite of a whole, which is an integer. It's just rational, because it's a fraction, and if it's rational, it's also real. Next one, -64. Square root of 64. Square root of 64 is 8. And that would be a negative sign on the outside, so it's -8. That makes it not a whole number, because whole numbers are only positive. So it's an integer. And if it's an integer, then it's also a rational. And if it's a rational number, it is also real. The negative square root of 10. There is not a number times itself that's going to equal 10. So it is not a perfect square root. If it's not a perfect square root, then it is irrational. And if it's irrational, it is also real. -2/3. Just because it's negative, it's not integer. Integers are only whole numbers and their opposites, not fractions. So it's a fraction. That makes it a rational number. And if it's rational, it's also real. Now let's look at the page you're supposed to be doing. Chapter 1, Lesson 7, Independent Practice. On the top part, 1 through 6, you are supposed to be labeling those as to what they are. You have to tell me. And I'd really like it if you'd spell out the words, because sometimes your handwriting is not real clear. So if you write out the word, I'm more likely to figure out what you meant. For example, let's do number 1. Number 1 is 19. 19 goes in the smallest circle. So that makes it natural. And if it's a natural number, it's also a whole number. And if it's a whole number, then it is also an integer. And if it's an integer, it's also a rational. And if it's a rational, it's also real. So you have to list all of them in number 1. Then write each number in the Venn diagram. So 19 would go in the smallest circle. I'm only writing it once. I'm not going to write 19 in all the categories. It goes in the smallest circle. If it's inside the smallest circle, then it's inside everything. And you're going to do that with all the first 6 problems. Number 7, 8 and 9, you're going to determine whether each statement is true or false. If the statement is true, explain your reasoning. If the statement is false, provide a counter example. So if it's true, you can just write true. But if it's false, I want you to tell me an example that makes it false. For example, number 7 says, all whole numbers are natural numbers. That is not true. Natural numbers is the smaller category, so that's false. What is an example of a number that is natural but not a whole number? Only one example. 0 is a whole number, but not natural. So that's my counter example. So on 8, figure out if it's true or false. If it's false, write me a counter example, an example that proves it is false. Same thing for number 9.